Hi all, this is Harini. Welcome back to our YouTube channel Code with Harini. Today we are going to solve date 22nd LeetCode July LeetCode challenge, which is maximum erasure value. So let's look into the question description. What does that mean? So they'll be giving an array of positive integer nums, and we want to erase a subarray containing unique elements. The score we will get by erasing the subarray is sum of its elements. So we have to return the maximum score that we'll be getting by erasing exactly one subarray. So an array B is called subarray if it forms a continuous subsequences of A, that is A of L plus, or if array starts from L to R, all the elements continuously present is called subarray. For example, here 4 to 4 is a subarray, 4 is a subarray. So continuously should be there. 4 to 4, 5 is a subarray. 4 to 4, 5, 6 also is a subarray of nums. So anything that you are taking, that should be continuous to. For example, you are taking 0 to 2, L is 0 or is 2, which means these is a 4 to 4 is a subarray. Okay, this is how the subarray indicates. So here what they have told, we have to return the maximum score by removing the exactly one subarray. Also that should have only unique elements. So subarray is a continuous element. So we will be check what here they have given nums and the answer is 14. So here if you see, they would have taken 4 2 first and it is 6. Okay, if you erase the subarray we will be getting 6, but if you erase this subarray, if you leave this 4, first 4, and if you erase this subarray we'll be getting 70. So we have to return the maximum score, right? So we'll be returning the maximum. So here if you see 5 to 1, 2 is repeating. So initially 5 to 1 comes, also 8, value is 8. So next 2 1 2 we can't take, because you can't take 5 1 2 like this, because it's not a subarray. We have to remove exactly one subarray, that should be so here 2 is repeating. So to pick this 2 we should traverse, we can't take this 5 2, we can take from 1 to 5. So this will also give us 8. So again when this 2 comes, we have to not take this 1 to include. So if you see 5 to 1, or again 1 to 5, so like this. Okay, it should have only one. We can remove any one subarray, that also it should be unique. Okay, I hope you guys would have understood the explanation. Let's look into the visual representation and how we are going to approach, what are the different approaches we have, time complexity and space complexity. We'll discuss all this in detail. Yeah, now this is the example that we are going to take. Okay, now for this particular example, what is the one exact one subarray that we are going to remove is, so you have to pick maximum number of unique elements until other element repeats. So you can take any subarray that until another element in the subarray repeats. Okay, so that we will be getting the maximum score, right? So if you see here 1 2 3 4 5, everything is until 4 comes. So we have to take subarray is a continuous element to so we have to verify all the subarrays that can give us maximum. Since already we have taken this 5, for sure taking this 5 elements will be greater than taking 1 2 3 4, whatever it is, right? So because how many maximum number of elements we are taking, that will give us a maximum score, right? So what we will be doing is whenever we are traversing, until the same element is present in the whatever the subarray that we are taking, we'll be keep on adding. So next when another element comes, then we'll be seeing at what point the another element is repeating. So we'll be removing all the previous elements. So from here again we'll be checking. So till here, if we are seeing our current sum will be 3 6 10 15. Okay, if you remove this 4, because now next to 4 comes, we can't take this 4. If you take, because subarray is a continuous element, you can't pick, you can remove 4 and you can take all this. That's not possible, right? So you will be removing all this 4. Okay, from this 5 we can take again. So 5 plus 4 is 9, 12, 27, 33. So we'll be picking up our maximum score as a 33 by taking this element. We just want to return the subarray. So this is the approach that we are going to use. Let's take a look at the example. So first we wanted a unique elements array to store, right? What are the unique elements? So and our current sum, currently it will be 0, and we'll be returning the max score that we have obtained by erasing any of the subarrays. Okay, so now for I'll be taking we will be getting nums, right? Okay, now if some num and unique elements, how we are going to handle? If not, what we'll be doing, will be straight away appending our unique elements. We'll be appending our unique elements to the nums. Sorry, num to the unique element. Now then we'll be adding our current sum plus or equals to num. Okay, then we'll be keep on updating our max score with max of current sum or max score, which is max, that will be returning, and will be returning our max score, right? So if unique element exists, okay, so this is the unique element, so we can't take any element. If you want to take this 4, we already calculated, so we have to return max of any, which is maximum score of exactly one subarray that we are going to remove. Already we have calculated this, so we don't want this. So that what will be our next score if you include this 4? Okay, so to include this 4, we'll be deleting all this. Okay, so what I'm thinking initially, will be taking an index, okay, of this and unique elements. I'm going to take index. Okay, now find what unique elements dot index, so that element index I'm getting. So tell that I am unique element equal to unique elements of index plus 1. So we'll be getting this index. We want to remove, you will be getting this index, so we wanted to remove till this particular index, right? So that's what index plus 1. After that whatever exists, so I'm giving now to unique elements. So for example, now unique elements will be 1 2 3 4 5. So this index I would have got, so I have to remove all those elements, so I'm just giving unique elements after that from index plus 1. Okay, I hope this makes sense. Now again we'll be setting our current sum equals to 0. So again we'll be appending this num to the unique elements, then we'll be updating our current sum 5 plus 4, then we will be keep on updating our max score. Every time we will be keep on updating the max score. Yeah, current sum is now got 0. Again it will be 5 plus 4 plus 3 8 7 6, so and it will get updated and we'll be returning the max score. I hope this makes sense. So maybe just I'll run through the example as well. So now we are going to take the same example as above. Okay, so first 1 will be getting added to unique elements. So 1 will be getting added and the current sum will be getting append to 1. Max score will be updated to 1. Then whether the 2 is present in unique elements, no, right? So 2 will be updating append 2 as well. Next, current sum plus or equals to num will be getting updated to 3. Max score will be getting updated to 2. So next 3 will come. Unique elements, whether it will check 3 is present in unique elements, no, right? So now we'll be adding it to the unique elements array. Then we'll be updating our sum plus 3 plus 4, sorry, 3 plus 3 already. Okay, current sum is 3 plus 3 is 6. Max score will be getting updated to 6. Next num is 4. 4 is in present in unique elements, no, update. 6 plus 4 is 10. So max score will be getting updated to 10. So element is 5. So 10 plus 5 is 15. So unique element doesn't have 5, so we'll be adding it to the 5. 10 plus 5 is 15. Max score will be getting updated to 2. So now here comes 4. So if 4 comes, where 4 present? Here, right? So until we remove these elements, we will be keep on having this 4. We can't take this 4 into an account to find whether another max score available, right? So what we will be doing, will be finding this index. Now again 4 comes. Now okay, that exists in unique element, so I'm going to find out the index, which will be 3. So index is 3. Unique elements now got updated to 4 to whatever the elements exist, so that we will be unique elements would have got updated to that. So which means only 5 left out. So we'll be updating our unique elements array with 5. Okay. So till here we have calculated. Right now from 5 we have to calculate, correct? So current sum will be not 0, it will be sum of unique elements till now. Okay, already current sum is got updated. Here is only 5 is exists, so we'll be giving 5. Now we'll be adding that num, right? So now 5 plus 4, which is 9. Then max score is already 15. So now it will not get updated to 9 again. So now when next element comes 4, so 4 gone, 3 will be coming. 3 is not an unique element, so if we would have updated to 5 4, and now 3 9 plus 3 is 12, so max score is still 15. That will not get updated. So again 8 comes. So 8 is not present in unique element, so it will get updated. 12 plus 8 is 20. Max score now will be getting updated to 20, right? So yeah, next 7 will be coming. So when 7 comes, 7 is in unique elements, no, then obviously it will get added 20. Now the current sum will be 27, right? So then max score will getting again updated to 20 to 27. 27 again 6 comes, that is also not present. So now 6 is in unique elements, no, now get added. 27 plus 6 is 33. So max score is getting updated to 33. In turn returns 33 as a answer. So now we have got 2 unique subarrays, which is 1 2 3 4 5 as well as 5 4 8. Among this, whatever the maximum we have written, right? It's kind of 2 pointers only, but in this approach we are using find index of this, right? So that itself will take order of k. For example, we'll have unique elements as a k element, so it will take order of k elements. then we are doing shifting, right? Unique elements till index plus 1 2 whatever it is, that shifting also will take order of k. So this is already order of n. To every time if same element repeats, we'll be keep on doing that order of k, right? So to the max, the time complexity for will go order of n square, and the space complexity is order of n to the max if all were unique elements. Will be storing all these elements in this array, right? So to the max burst time complexity can be order of n square and order of n. So to here we are using an array. So to perform order of one operation, unique elements index will take order of k to shift to get the index, as well as to for shifting the elements. Will be using set, which uses order of 1 to add as well as remove from the elements. So now how we are going to do that? Let's take a look at that example. We will not do anything the same, we will be doing exactly the same way. So what they will be having the same unique elements, current, sum and max, everything. Instead of unique elements as an array, we will be taking unique elements as a set. That's it. So and we'll be having left pointer and right pointer, left, right, and current, sum, max, score, everything as a 0 initially. So what we will be doing, we'll be having a right in range length of nums. So if here, if the num and unique elements, what we are doing, we'll be finding the index, all those things, right? Instead of that, while nums of right in unique elements, what we'll be doing, we'll be keep on removing it from the unique elements set. Unique elements dot remove nums of left. So what we'll be doing, until this element we have to insert, until this element is there, we are doing finding index, and we are doing shifting to the next index. So here what we will be doing, we will be keep on popping it out, okay, by a left pointer. So left pointer initially will be here at the start of the array. So what we'll be doing, we'll be popping out unique elements dot remove left until nums of right is not in unique elements. So that's what we are doing it here. Remove and current, sorry, first okay, current sum minus or equals to nums of left, current sum also we are minusing, as well as what we are doing, we'll be doing left plus or equals to 1. Okay, so here even to calculate the current sum also we need again sum will be traversing order of k. So to avoid all these things, we'll be subtracting via one traversal. You remove as well as you minus the subtracted from the current sum here. Then if not, unique elements is not there, the same unique elements dot add update the same. So unique elements dot add nums of right, current sum plus or equals to nums of right, as well as we will be updating the max score equal to max of current sum or max score. Okay, we'll be returning the max score at the end. Okay, I hope this makes sense to you guys, how instead of this, why we are putting, it's just a 2 pointers. So now left will be traversing once. So left pointer would have traversed once till the array. Right pointer also will be traversed. So it's like technically order of 2n. To remove from the set and add it to the set will take order of 1n point. So that's why we are taking set here. So the time complexity will be order of 2n, technically order of n. Space complexity will be the same order of n to have it in a set, right? Yeah, to just run through the example, yeah, as usual, for right will unique elements will be keep on adding it to the set 1 2 3 4, and the current sum will be updating it to the 1 2 3 4 5 till that it will be keep on adding. Current sum would have got updated to 50, max score will be 50, the same. So now the question comes here. Now when you are adding another 4 into the array, that is nums of right, in right will be 5. Okay, that nums of right is 4, that is in unique elements, right? Till then we, this is our left, initially left was 0. Okay, so what left was 0. Now we'll be popping out the remove 1. First I have removed the left, and left got incremented to 2. Now you remove this nums of left, which is 2, also remove. Then current sum got subtracted, 3 also, some current sum would have got separated, and current sum would have left with 5. At this point we would have subtracted 4. Now nums of 4 is in unique elements, no. Now current sum left with 5. Again it will keep on adding the 4 3 8 7 6, and at the end we will be getting max square is 33, as how we got here. So yeah, just we have updated the removal logic, why we are using set. I have explained. I hope this makes sense to you guys. This is the exact solution that I have used to solve the problem. That solution I will be posting in LeetCode as well as in the GitHub link that will be given in the description. Please do check out. If you have any questions, please do leave a feedback. I'll be happy to help. If you have please do like, share and subscribe, and share it to your friends as well. That will keep me motivated to post the videos daily. Yeah, thanks for watching.